The straight line plot for the second order reactions is, as you could probably guess, a straight line. But unlike the first order reactions, this straight line plot is not an inverse function. It's a positive straight line. So the straight line plot would look like this. And they differ because, unlike the first order reaction, the initial concentration is not independent of the reaction, so that's why it is different as so. Let's do another example pertaining to the second order. Okay. Let me write this out real quick. The decomposition of XY, which is just the reaction, is second order in XY and has a rate constant of 7.02 times 10 to the negative 3 molar. I mean, not molar, but you know what I mean. Okay. This is a two-part question. It says, A asks, what's the half-life for the reaction at an initial concentration is 0.1 molar. Wow, that's a long time to write out. So, what's the half-life of the reaction when the initial concentration is 0.1 molar? So, knowing that for the second order reaction, this is the half-life expression. All we have to do is write it out. Half-life is equal to 1 over the rate constant, which was told above, which is 7.02 times 10 to the negative 3 times the initial concentration, which is 0.1 molar. And to solve this, you just put it in your calculator. So you put 1 divided by 7.02 times 10 to the negative 3 times 0.1 molar. And when entering this into your calculator, you want to make sure that you use a lot of parentheses so that you don't get the wrong answer. And the answer for this, the half-life will be 14.25 seconds. And that would be the half-life for the second order reaction. Now, last but certainly not least, we get to discuss the zero order reactions. Okay. For the zero order, the half-life is expressed as half-life equals the initial concentration, is AO, over 2 times the rate constant. And that's the half-life expression for the zero order. The integrated rate law for the zeroth order is the final concentration is equal to negative K times T plus the initial concentration. That's the integrated rate law. And the straight line plot for this function is more or less, it's the same concept as the first order reaction, as they're both inverse functions. And they both have a negative slope, t. That's shown here. Zero order reactions are probably like the, I don't want to say least, but they're probably the least used reactions. Or the, not least used, but least common. And that concludes all of the orders of reaction for half-life. Thank you for taking the time to listen to my little video, and have a great day.